Today I will be talking about how rare earth elements or REEs can be recovered from iron ore tailing. This is an emerging field that not only addresses the growing demand for these critical elements but also contributes to environmental sustainability and resource security. Rare earth elements are essential for modern technologies. They are used in electric vehicles, wind turbines, electronics, and many high applications. Global demand for rare earth element is projected to reach nearly 240,000 tons by 2030. However, the challenge is that primary ore resources are limited and geopolitically sensitive, creating a risk in supply. This is where the recovery from secondary sources like tailing becomes highly important. So, why recover rare earth elements from iron ore tailing? Iron ore tailing are often seen as waste, but they actually contain valuable rare earth element such as cerium, lanthanum, and neodymium. By recovering rare earth element from the tailing, we achieve multiple benefits, reducing environmental impact, promoting the circular economy, and enhancing resource security. So, globally, studies show tailing with rare earth element concentration around a median of 146 milligram per kilogram, making them a promising resource. Typical rare earth element content in iron ore tailing, uh, the major rare earth elements commonly found in iron ore tailing are cerium, lanthanum, and neodymium. Their concentration vary depending on location. For example, tailing from China, the USA, and India shows comparable ranges. When we compare this value with some primary ore, the tailing actually show significant and exploitable rare earth element content. This is why serious attention is now being given to tailing as a secondary rare earth element source. Several recovery methods are being explored. On the physical side, techniques like magnetic separation and flotation are used. Chemically, methods such as acidic or alkaline leaching, solvent extraction, and even bioleaching are applied. Emerging technologies are also making progress, such as electrokinetic assisted phytomediation and advanced bioleaching, which have achieved up to 90% recovery in some cases. On successful approach, one successful approach is suspension magnetization roasting. This process enhances iron preparation and helps concentrate rare earth elements. A notable example comes from uh, Ben Obo deposit in China, where researchers achieve 92% rare earth element recovery with a grade of 8.5% from tailing. The advantage of this method lies in improved magnetic properties, which enable better physical separation of rare earth elements. Another promising method is bioleaching. Here, microbes are used to extract rare earth elements under ambient condition in a sustainable way. Compared to traditional leaching, bioleaching is less costly, generate less toxic waste, and is especially effective for low grade tailing. Of course, challenges remain in scaling this method, but ongoing research is working to overcome these hurdles. Looking forward, new technologies are showing exciting potential. For instance, hydrogel absorption is being studied for selective rare earth element recovery from mine drainage. There is also a growing focus on integrating physical and biochemical methods to achieve higher efficiency. But technology alone is not enough. We need strong legislative support and industrial adoption to truly move towards a circular rare earth element economy. Globally, iron ore tailing represent vast secondary source of rare earth elements. Recovering them reduces dependence on imports, support green technologies like EVs and renewable energy, and strengthen supply chain resilience. Importantly, it aligns with the global sustainability goal, making it both an economic and environmental priority. To conclude, iron ore tailing are no longer just a waste product. They are a promising secondary resource for rare earth element. By combining physical, chemical and biological recovery methods, we can tap into this resource very efficiently. The strategic importance of rare earth element in future technologies and sustainable mining makes this field very critical. A coordinated effort among industry, policymaker and researchers will be very much essential to unlock its full potential.